this video, we are going to prove that a raised to the n plus 1 minus 1 equal a plus a minus 1 times a raised to the n plus raised to the n minus 1 plus a raised to the n minus 2 and plus all the way and so on to a plus 1 for every positive integer n. So we are going to use the principle of mathematical induction to show that this equation holds for every positive integer n. Now let's get started. The first thing we are going to do is to let Pn be this equation. A to the n plus 1 minus 1 equal a minus 1 times a to the n plus a to the n minus 1 plus a to the n minus 2 and plus all the way to a and plus 1. Okay, and then we use the principle of mathematical induction. Okay, principle of mathematical induction and start with the base step. The base step is the step where n equal 1. So when n is 1, what do we have? So we have to start with a to the 1 plus 1 minus 1. We start from the left side of the equation. So we're going to have a squared minus 1, which is a minus 1 times a plus 1. Okay, we have a plus 1 right here. Now what about this a plus 1? This a plus 1 is from this one right here. So we let n to be 1, so we're going to have a to the 1 and plus a to the 1 minus 1. Okay, so it turns out to be a minus 1 times a to the 1 plus a to the 0. Okay, and which is a minus 1 times a to the 1 plus a to the 1 minus 1. And a to the 1 minus 1 is just 1. So we have that. We have the case where P of 1 is true. Okay, P of 1 is now true. And then let's take a look at the inductive step. So what is this step? In this step, we have to assume that P of k is true. Okay, for every positive integer k, and try to show that P of k plus 1 is true. Okay, try to show that P of k plus 1 is true. So we might start with P of k plus 1, which is true. Okay, so let's try to write a to the k plus 1 minus 1. Okay, just plug in k plus 1 into n. So we gotta have a times a to the k plus 1 minus 1. Oh, let's use this assumption. We have the case where P of k is true because we can transform this term into something. So we need to start with this. Since P of k is true, what do we have when P of k is true? Then we gotta have a to the k plus 1 minus 1 equal to a minus 1 times a to the k plus a to the k minus 1 plus a to the k minus 2 and plus 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 all the way to a plus 1. Okay, and then we will substitute, we will rewrite a to the k plus 1. Okay, so we gotta have a to the k plus 1 equal this term n plus 1. Okay, n plus 1 right here. All right, then what do we have? Okay, from this term right here we gotta have a to the k plus 1 minus 1 equal a times a minus 1 times this term here. Okay, this time this term, okay, this one right here, just substitute a to the k plus 1, and it turns out to be this. Once you substitute, do not forget to have minus 1 here, minus 1, because this term here is just the one that inside this angular bracket. Now we distribute this a, so we gotta have a times a minus 1 times this term. Okay, and we distribute a to plus to 1 right here, so we gotta have a minus 1. And what do we have? We have a minus 1 here, so we factorize a minus 1. Okay, so we gotta have a minus 1, and okay, we factorize this term, so we gotta have a times this guy right here. Okay, and plus 1, n minus 1, sorry, n plus 1. Okay, n plus 1, n plus 1, because this a minus 1 right here has been factorized to be here, so this term become 1. Okay, so we distribute this a, so what do we have? We gotta have a minus 1 and a to the a plus 1 plus a to the k plus a to the k minus 1 and plus 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 a square plus a and plus 1. Okay, so we distribute this a, so this term becomes a term with a, and the last term is now 1. Okay, so we have shown that when n is k plus 1, we have n becomes k plus 1, k minus 1, and all the way and so on to a n plus 1. So we have shown that p of k plus 1 is true. P of k plus 1 is now true. So once it's true, what do we have? So we have proved the inductive step. Therefore, we have shown that. Therefore, this equation a to the n plus 1 minus 1 equal to a minus 1 times a to the n plus a to the n minus 1 plus a to the n minus 2 and plus 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 all the way to a plus 1. Okay, so this equation is true for all positive integer n. Okay, so we have proved this statement already. That's it for this video.